Today we are going to be learning about the geometric mean. So our learning target is how can I use ratios, proportions, and the geometric mean. Ratios. A ratio of two numbers A to B, where B does not equal 0, can be written as A over B, a fraction, or the ratio of A to B, so A colon B. We're going to simplify the following ratios. The first ratio we have, 64 meters to 6 meters. So we can write that as a fraction, 64 meters over 6 meters. And reduce. Well, the meters are going to cancel. Meters divided by meters goes away. 64, we can divide that by 2 and get 32. And 6, we can divide by 2 and get 3. That is as simplified as it can go, and so we do want to write it in the way that it was given to us, so we write it as the ratio of 32 to 3. Second ratio, if we look, we do not have common units. Our units, one is feet, one is inches. So we first need to multiply by a conversion factor. It'd be easiest to make feet into inches, so our conversion factor is going to be 12 inches per 1 foot. That is a ratio in itself, the ratio of inches to feet. Multiply through, we get our feet are going to cancel, our inches are going to cancel. 5 times 12 gives us 60. 20 times 1 gives us 20. Reduce that into simplest form, we get the ratio of 3 over 1. Last ratio, 24 yards to 6 yards. Same unit, so we are good. Write that as a fraction, 24 yards to 6 yards. Yards are going to cancel. 24 over 6 can reduce to 4 over 1. We can leave it as, no, we cannot leave it as a fraction. It was given to us in our ratio form of 4 colon 1, which is what we would want to write our answer as. Next problem. The measures of the angles in a triangle have an extended ratio of 3 to 4 to 5. Find the measure of the angle. All right, so first things first, let's draw a picture of a triangle. We're working with a triangle. We should give ourselves a nice image of a triangle. So we have a triangle. Just draw a triangle. Now let's make it triangle A, B, C. We know that the angles have a ratio of 3 to 4 to 5. So they're not going to be congruent angles. They are going to be different angles. Now what this means is ratio of 3 to 4 to 5 means your angle measures are going to be a multiple of 3, 4, and 5. So we could say 3 times 2, 4 times 2, 5 times 2. So it could be 6, 8, 10. We could multiply we can multiply 6, 8, and 10 by 2 and get the ratio 12, 16, and 20. So our angle measures are going to be, one is going to be 3x, 3 times some number, but it's going to be x, and then 4x, multiplying by the same number as we multiplied 3 by, but now we're multiplying it by 4, and then 5x. So we know they have that ratio of 3, 4, 5. We just need to find out which number are we multiplying the 3, 4, and 5 by. Now, we're looking at measures of an angle. Well, we have a theorem that talks about measures of an angle of a triangle. We know that they sum to 180. So using that fact, we could say that 3x plus 4x plus 5x is going to equal 180. add your like terms. We get 12x equals 180. Divide both sides by 12. And x equals 15. Well, we don't just want to know what x is. We want to know what's the measure of each angle. So 3 times 15 is 45. So one measure is 45 degrees. 4 times 15 is 60. So one measure is 60 degrees. And 5 times 15 is 75 degrees. So our angles are 45, 60, and 75. Next piece is proportions. This should be familiar to you guys. A lot of this would have been done in 7th grade. An equation that states that two ratios are equal or equivalent is called a proportion. So two ratios that are equal is called a proportion. If you look here, we have one ratio set equal to another ratio. We're calling letters C and B the mean and A and D the extreme. All right, this goes to help us understand the cross products property. In a proportion, the products of the extremes, so products of A and D, equals the products of the means. So makes that x, that cross multiplication. So we can say that A times D equals B times C. You multiply your two diagonals. 3 times 4 equals 12. And 2 times 6 equals 12. So solving the following proportions. If we do our cross multiplication, we have 5 times 16, which is 80, and equals 10 times x, which is 10x. Divide both sides by 10, so we can solve for x. X equals 8. For our second example, do your cross multiplication. 1 times 3y is 3y, which is equal to 2 times y plus 1. Make sure with that you are using distribution. You're multiplying a sum. So we would get 2y plus 2. Get your variable to one side by subtracting 2y from both sides. We get 1y equals 2, so y equals 2. Real-world example, science. As a part of an environmental study, you need to estimate the number of trees in a 150-acre area. That's an important number. Let's box that. You count 270 trees in a 2-acre area. You notice that the trees seem to be evenly distributed. That's an important feature. Estimate the total number of trees. Well, we know that we have 270 trees in a 2-acre area. So if we think about a ratio, we're comparing two things to each other. We're comparing feet to inches, yards to feet, gallons to miles. We have lots of things that we compare. So here we're comparing number of trees to acre area. So if we use this piece right here, we know that there are 270 trees per 2 acres. The only other information we are given is that we're looking at a total of a 150-acre area. So we're setting up a proportion. We can put that on the bottom. that leaves us to estimate the total number of trees. So we have X trees per 150 acre area. Now the reason we're able to set up this proportion is because they were evenly distributed. Since they are evenly distributed, a proportion does work. Here we want to multiply our cross products. We have our cross product of 270 trees per 150 acres. Well, 270 times 150 is 40,500. Our other cross product is 2 acres times x, so 2 times x is 2x. Get x by itself, divide by 2 on both sides. And we get x is 20,250. So that would be the number of trees, about the number of trees in the 150 acre area. Last piece, the geometric mean of two positive numbers, a and b, is the positive number x that satisfies the proportion a over x equals x over b. So that would mean x squared equals a times b. We would get that by doing our cross products. X times x is x squared equals a times b, a, b. We can take that one step further and get x equals the square root of a times b by taking the square root of both sides. The square root of x squared is x. Square root of a times b is the square root of a times b. So using that formula, that equation, we want to find the geometric mean for the following two numbers, 24 and 48. These are our a's and our b's, and we want to know what is x. So we say x equals the square root of 24 times 48. Big numbers. Use a calculator, and we get 24 times 48 is 1,152. So x equals the square root of 1,152. That's a pretty big number. I'm not quite sure where that is, what two numbers it lies between. So if I use my calculator to give me an approximate, that gives me 33.9. So I can say about 33.9. And that's all you have to do. So the second one, the geometric mean of 12 and 27. So we have our a and our b. So we know x equals the square root of 12 times 27. Again, big numbers. Feel free to use a calculator. 12 times 27 is 324. So we have x equals the square root of 324, which is approximately, it's not approximately, it is exactly 18. So we could say x equals 18. Last one, 6 and 18. So 16 and 18, excuse me. We have our a and our b. We have x equals the square root of 16 times 18. 16 times 18 is 288, so x would be equal to the square root of 288. Get an approximate of that so we have a good idea of what that number is, and we get 16.97. So it's approximately 16.97. That's all the notes I have for you. Thank you for watching, and please subscribe to my YouTube channel.